Alright, here's our Honors Geometry 3.6 notes video. We're going to talk about distance today. So the first thing is, if you wanted to jump across a creek, so suppose you're jumping across a creek, or you're long jumping, or you're, I don't know, Spider-Man trying to get from one building to another, how would you jump across that creek? What path would you take? Would you take AB, AC, AD, or AE? And why? Well, of course you take AC because it's the shortest path. And the big idea here, the key to the whole lesson, is that that path is perpendicular. So our whole focus today is going to be, how can I get from a point to a line? What's the distance? And it's going to be perpendicular. So we've got some vocabulary. You can always pause the video and just get this vocabulary down. That'll probably be the easiest way to do it, and then unpause when you're done. So example 1, construct the segments that represent the distances indicated. So we're going to do C to AB on these first two, and then D to AB after that. First one, C to AB. Again, when you're finding distances, it's always perpendicular. So you want to draw the perpendicular distance from C down to AB. Or here, from C to AB, where would be the perpendicular line from C, perpendicular at a right angle to AB. And then on this one, I'll give you a hint. You got to extend your lines a little bit. What would be the perpendicular distance from D to AB? And I'll give you a few minutes to try this one on your own. You can always pause the video and then unpause to check your work. Alright, so here's the answers. Straight down, perpendicular. Here, kind of a tricky one, straight down is just the segment CB. And then here, you're going to be outside the quadrilateral to get your distance D down to AB. And notice that this is something that's going to come up later in chapter 4 and 5. You can move this, right? So B up to that intersection point at the top is the same distance as D down to AB. So this is the same distance, assuming those two lines are parallel. All right, so how do I find the distance between one pair, two lines that are parallel? First, determine the point you're starting at, then determine your slope for the distance. Then we're going to write our equation in our distance formula format. Okay. So I want to find the distance between these two lines. First of all, we should probably graph them. And I want to find the distance between these two lines. Now you can use any point in the world, any point you want to use, does not matter, to find the distance. But what I'm going to suggest is that you use a positive number, and I would also suggest using a y-intercept. It's probably just going to be easier that way. So I'm going to go from this dot right here to this one. Just an arbitrary point that I chose, doesn't matter. You could pick any point in the world you want, as long as it's on one of those lines. So this is 0, 4. I picked that point just because I like it. Now to get from that line to this line, I need a perpendicular distance, or perpendicular slope rather, to find the distance. So I need to figure out what's perpendicular to my slope of 2 over 1. Well, that would be negative 1 over 2. So I'm going to do my slope of negative 1 over 2 from my starting point. Draw my perpendicular line, and I'm going to look at where in the world do I intersect my two lines. What two intersection points do I have? One of them we already knew was 0, 4. This one over here is 1, 2, 3, 4, comma 2. So 4, comma 2. And I want to know what's the distance between these 2 points, because that is this distance. What is that distance? That's what I'm hoping to find. So then I would use my distance formula of x2 minus x1 squared plus y2 minus y1 squared. And you end up getting, what is that? 4 minus 4 is 16. So the square root of 4 squared plus 2 squared. And it's a negative 2, I know that. But when you square it, the negative goes away, which would be 20. Or you could write this as 2 root 5 or 4.7, somewhere in there. That would be my distance. Same thing with B. First thing you want to do is identify your two lines. There they are. Those are my parallel lines. They have the same slope. And I've graphed my lines. And I want to figure out, how am I going to find the distance between those two? They need to have a parallel slope, these two, and they do. So to find the distance, I need a perpendicular slope between them. So perpendicular slope here from 3 over 2 would be negative 2 over 3. So I'm going to go back to my starting point, and that's 0, 6. And again, you could pick any point on either one of these two lines. It doesn't matter at all. I just like to pick the positive y-intercept because it tends to be an easier one to use. You avoid negatives at least as much as you can. And now I'm going to take my negative 2 over 3 slope, my perpendicular slope, and I'm going to plot that slope and see if I can figure out where my two intersection points are. One of them we already know was 0, 6. The other one is right here at 6, 2. Right? 1, 2, 3, 4, 5, 6, comma 2. So I want to find the distance between those. I'll use x2 minus x1 squared plus y2 minus y1 squared, which would be 6 minus 0, and 2 minus 6, which ends up being the square root of 36 plus 16, or the square root of 52, which is 2 root 13. Okay, you can check out the other video on the homework problems. If you need that, just ask me. It's unlisted, so I'll send you the link to that one. Other than that, let me know what questions you got. Send me an email or stop by before school.